right. What we're going to do is I'm going to quickly go through domain and range and how to identify this using two different examples um, where you can find the domain both algebraically and you can do it graphically. And for range, mainly what I do is I use it graphically. So without further ado, let's look at our first example. We want to find the domain and range of our different functions. So in this example number one, let's look at our domain. Now domain is our input or x values. So when we look at this, we can first look at it algebraically and take a look at our equation. And what we notice in our equation is, all right, we've determined that it's going to be all reals, okay, all reals, negative infinity to infinity, unless we divide by zero, because we can't divide by zero. So look at our denominator and realize that there is no values that can go in the denominator. That will make it 0. All right, so denominator is never 0. And also there's no square roots, so this is our domain. We can verify that graphically by identifying that in our graph there are no holes, no vertical asymptotes. It goes on forever. For every input there is one output, okay? And as you plug in x values, you get outputs, and therefore all the values along the x-axis, because x is the domain, are used in this function. We can see that along this axis right here. Okay? Color, our domain. All right? All right, now, for our range, just so everybody knows, is the y values. Okay? The range is our y values. All right? Our y's are our outputs. Now, in this, it's a little bit different because our range is dependent upon what we plug in. So as we plug in these values, we have to look and verify what y values, and the y is the vertical axis. All right, the y is the vertical axis. So now we are looking up and down. So we're trying to figure out, along this axis, which y values are being used. Well, we can see this by determining what is the highest and lowest values. And right here, we notice that the bottom point right here begins at 0. Okay, so our range begins at 0. And it does equal 0, so we'll have starting at 0. And how high does it go? Well, it's hard to see right here. I'm going to erase some of this stuff. And we realize it looks like a horizontal asymptote at 1. And at this, we can use some limits and other things to actually determine this. But graphically, we can plug in some values and realize that it does level off at 1. And there is actually, it never reaches 1, okay, because that horizontal asymptote. So our range goes from 0 to 1. All these values, all right, in between are also used. And we'll have an open parentheses because that means it is not equal to. Okay? So that is our range. That's our range. So from 0 to 1. Over here in example number 2. In example number 2, we also have a g of x. And we can find our domain, our x values, by looking at this function. We can determine, okay, it appears I can plug everything into here except the bottom can't equal 0. And so I guess x itself cannot equal 1. So all values can plug in, but x it can't equal 1. All right, x can't equal 1. So if you want to write with this function notation, go negative infinity to 1, and then 1 to infinity right there. We have our parentheses right here because it's an open interval. It cannot equal. When you look at that. All right, now, okay. Now, on the graph, when you look at this, the domain, usually in calculators, they do not give you open circles. Now, usually in books, they do give you those open circles, like so. But that's where looking at the function itself is so useful, because the function you can determine much from it if the graph is inclusive, or it's not really, you're not really sure what you're looking at. But looking at this, you can now determine, yeah, except that 1, everything else, oops, wrong color, all right, everything else does work out. It appears that starting here, everything over here, I have this, I get an output, and over this, I get an output. Even though they're all the same, those are my outputs. Now, the range, my outputs that I get out, the y values, once again, the vertical axis, is a little different. This is a little strange because it's different than everything else and even the previous problem, is that you realize that, well, it appears that we're only using 2 outputs. So my range right here is right, of just two values. What we have is 1, right? What we have right here, just 1, it's just this horizontal line, and nothing in between, and then we have -1. So we can write, all right, we are using -1 and 1. Okay, and we have that set of those two different values for y. You know, you can also probably write y can only equal -1 and 1, and that is your range, and that's about it. So once again, domain is your inputs, is the input /x, and the range is the output, which a lot of people know as the y value, all right, or the vertical axis. All right, hope that helps out how to find domain and range, both how to do it analytically and also using a graph.